Okay, let's review how to solve multi-step equations, and then we'll describe their solution set as either exactly one solution, no solution, or infinite solutions. So on this first one, we must distribute the 1/2. So when we multiply by 1/2, we're really dividing by 2. So we get 3x minus 3 equals x plus 12. Now, when you have variables on both sides of the equal sign, we need to address the variables before the constants. And my rule of thumb is to get rid of the smaller variable. So I'm going to subtract 1x from both sides. Now we're solving for x, so we need to add 3 to both sides. Then we're going to undo multiplication by division. And x is going to be 15 over 2. You can leave it in this form, or if you want to convert it to 7 1/2 or 7.5. So this solution, or excuse me, this equation has exactly one solution. This means there's only one value that if we plug in for x, we will get a true statement. So 7.5 is the only value that will make the left side equal the right side. Okay, now let's go to our next one. In this example, we need to first distribute on the left, and then we can go ahead and combine like terms on the right. So we're going to distribute the 2, and we get 2x minus 2. When we combine 1x and 1x, we get 2x plus 1. Again, we have variables on both sides, so we're going to address the variables before the constants. These variables are the same, so they are going to be eliminated, and we end up with -2 equals +1. So when you have no variable and a false statement, this means there is no solution to this equation. There's no value that will ever make the left side equal the right side. In our last example, we need to combine like terms on the left, and then we'll distribute on the right. So 3x minus 1x is 2x plus 4 equals, and we distribute the 2, we get 2x plus 4. We're going to address the variables before we address the constants. Again, these variables are the same, so they will be eliminated. And we have a statement that is true. We have no variable with a true statement, so this means that we have infinite solutions, meaning any value will make this left side equal the right side. Let's take a look at a few word problems. We're going to write a formula and identify the components within an expression and then create the equation. So a rectangle has a perimeter of 108 units. So we're dealing with a rectangle. So the length is 6 less than 4 times the width. Determine the dimensions of the rectangle, which means dimensions means the length and the width. So the formula for perimeter of a rectangle, so remember perimeter, is distance all the way around. So we have a length, a width, a length, and a width. So perimeter is always adding all the outside lengths of an object. So here our perimeter is we have 2 lengths, and I'm going to put the length in parentheses, plus 2 widths equals our perimeter, and in this case, we already know that it is 108. So now we need an expression for width and length. So let's go back to the problem, and it says the length is 6 less than 4 times the width. So we know something about length, but we know nothing about width. So I'm going to let width be x. And now let's take this x to represent the length, because remember, we can only use one type of variable in our equation. So I can't use like x and y or L and W. So the length is 6 less than. So less than means we need to flip this around. So it's going to be 4 times the width, which is x, minus 6. Now here is the thing you need to make sure to not forget, and this is why, one, I use parentheses. Now we're going to use our formula to create the equation. So this is very important part of the process. So I have 2 lengths, so we have 2 parenthesis, length is 4x minus 6 plus 2 widths, which is x, and that equals 108. So now we have our equation. So we're going to solve for x, which is our width, and then when we get that, we can then find the length. So we're going to distribute, and we get 8x minus 12 plus 2x equals 108. Now we're going to combine like terms. We get 10x minus 12 is equal to 108. Now we're solving for x, so let's add 12. Let's divide by 10. This should be 20. And then when we divide, x is 12. So the width, x, is 12. And the length is going to be 4 times 12 minus 6. So 4 times 12 is 48 minus 6 gives us a length of 42. So the length is 42 and the width is 12. And if we were to add all these around, we would get the 108. Jill charges a diagnostic fee of $70. She charges $30 an hour to fix the issue. Jan charges $20 an hour with a diagnostic fee of $100. So each of them have a starting fee, the diagnostic fee, and then they have an hourly rate of $30 an hour and then $20 an hour here. So they have an upfront fee and then an hourly fee. The question is, at what hour will they charge the same amount, and what will that amount be? So we want to know when Jill's charges equals Jan's charges. So that's going to be the formula. We want to know when Jill's charge is the same as Jan. Now we need to represent Jill and Jan each as an expression. So I'm going to say that X is going to be hours. So I'm just going to identify this to find our variable X. So Jill charges $30 an hour plus her diagnostic fee of $70. Jan charges $20 an hour plus her diagnostic fee of $100. Now we're going to use our formula and replace Jill with her expression and Jan with her expression. So one charges a higher hourly and one charges a higher diagnostic. So we have variables on both sides, so we're going to always address our variables first. I'm going to choose to move the smaller one, so I'm going to subtract 20x, and we're going to get 10x plus 70 equals 100. I'm going to bring that up here. And we're going to isolate x, which is hours, because the first part of the question is, at what hour will they each charge the same amount? So at hour 3, they will both charge the same amount. Now to see what they will charge, so at hour 3, and then we're going to see how much they will charge. So you can plug it into any of the equations. It does not matter. So I'm just going to go with Jan. So 20 times 3 plus 100. So 20 times 3 is 60 plus 100 gives this $160. So at 3 hours, they will both charge $160. Before that and after that, they will each charge something different. Jace is 10 more than twice as old as Ben. The sum of their ages is 46. How old is each person? So we have Jace, his excuse me, his age plus Ben equals 46. Jace is 10 more than twice as old as Ben. So I know nothing about Ben, so I'm going to let Ben be X, and then I'm going to use X to represent Jace. Jace is 10 more than twice as old as Ben. So more than is, again, one of those flip-flops where we flip this around. So to represent twice Ben, and Ben is X, we say 2X plus 10. Now, let's take our formula and replace Jace with our expression. 2x plus 10 plus, here's part of the formula, Ben is x equals 46. So now we have an equation. We're going to combine like terms. 3x plus 10 equals 46. We are going to isolate x, which is Ben's age. So Ben is 12, and Jace is 2 times 12 plus 10. 2 times 12 is 24, plus 10 gives us 34. And if you have 34 and 12, you get 46. I hope this helps.